Okay, now we're continuing on number 10. And on number 10 on the Unit 3 review, we have a squirrel that's in a tree holding a chestnut at the height of 46 feet above the ground. It drops the chestnut, which lands on top of a bush that is 36 feet below the squirrel. This function right here gives the height in feet of the chestnut as it falls, where t represents the time. It says, when will the chestnut reach the top of the bush? Well, first of all, let's give ourselves a visual of what's going on here. So I'm going to go ahead and draw myself a tree. I am not an artist. So there we go. There's my tree. Then we have a squirrel that's inside this tree. So I'm going to go ahead and put a little squirrel. No. Okay, so there's my squirrel. And it says that this squirrel is in this tree, and it's at a height of 46 feet above the ground. So if this is the ground, this is my squirrel, then we're talking about the squirrel being 46 feet above the ground. Okay. And now it says that it drops this chestnut, so boop, 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 oops, drops the chestnut, and it's going to land on top of a bush. So we have a bush that's down here. And it's going to land right there on top of that bush. And it's going to be 36 feet below the squirrel. So if this is the squirrel, this right here drops below the squirrel. So the 36 feet is from the squirrel down below. And it gives the height in feet of the chestnut as it falls for this equation right here. So we want to find out, when will it reach the top of the bush? Well, it's going to reach the top of the bush when the bush is what height? What is this height from the ground? Well, if I know it's 46 feet down and it's 36 feet down to here, how much is left? 46 minus 36 gives you 10 feet. So it's 10 feet above the ground for this chestnut. So there are two ways to solve for this. So in order to solve for number 10, part A, there's two methods. So method number 1 involves you, and you'll get the same answer. Method number 1 involves you using your graphing calculator. By the way, both methods involve graphing calculators. Is to put one equation in, which is the negative 16t squared plus 46, and then putting the other equation in, which is this 10 feet. What we're going to do is we're going to graph this, which is a parabola, and we're going to graph this, which is a line at 10 feet high. And we're going to look for where the two of these graphs cross. Where do they intersect? And where they intersect will give us our value for the time, keeping in mind time is your x value. Okay, so let me go through the steps on how to graph this into your graphing calculator. So your first step is to go ahead and hit the y equals button. Let's see, there we go. So hit the y equals button, which is right here at the very top. And then we're going to put in the two equations. Now keep in mind, the negative 16, you have to use the negative sign, which is underneath the 3 in the graphing calculator. So underneath the 3, you cannot use the minus sign or it'll say error. Okay, so negative 16, and then the variable button is this x right underneath the mode right here. That's your x. And then squared plus 46. That's one equation. Then you're going to hit enter or arrow down to the next line and put in the 10. All right, if you hit just graph, normal graph, it's not going to show up because this is 46 feet up, and the graph for a normal graph doesn't go that high. So we're going to go to zoom, and we're going to go an arrow down until it says zoom fit. So you hit the zoom button first, so zoom is right here, and then you arrow down until it says zoom fit. So go ahead and select zoom fit. And you'll notice that we'll have the parabola right there. And then you'll see that red line, which is the 10. We want this to where it crosses. Now, we're looking for what is the x value. We have a negative and a positive where they actually cross. We have 2 points. Well, can you have negative time? No, you can't. So the only possible value is the one that's right here, which is the positive value. But it's kind of hard to see what that value is. So in order to do that, we're going to have the calculator calculate it for us. So we're going to go ahead and hit the second button, which is right here. And we want it to calculate for us, which is this button right here. What we want it to calculate is where they intersect, which is number 5. You can hit 5 or hit enter after you arrowed down to 5. And now I'll say first curve, because you can have many curves going on here. And we only have 2 at this point. But yes, this is the equation I want to use. This is the equation of the parabola. So I'm going to go ahead and hit enter for yes. The second curve, yes, that's it. Now, since it's on both sides, I want it closer to the right side because I want the positive value. You don't have to be right on top of it, but I'm just arrowing to the right, so I'm closer to that. So if you hit enter, you just chose the second curve. It says guess. Yes, I want it to guess. What is that answer? Hit enter one more time. And the x value, which is your time, is 1.5. So the time that it's going to take is 1.5 seconds. All right, that's one method. And then the other method is, again, using the graphing calculator, but we are going to simplify before we put it in. So method number 2 is basically plugging in the 10 feet in for the y, because we want to know when will it be 10 feet. 10 equals negative 16t squared plus 46. And then we're going to move everything to one side of the equal sign so it equals 0. So I'm going to subtract the 10. And then that's going to get me negative 16t squared plus 36 and then equals 0. So now we're just looking for the zeros of the graph. So I'm going to go ahead and go y equals, and I'm going to change this to be 36. Remember, this is still for part A, just another method. I'm going to clear that out. When I graph this, and you can go to Zoom Graph, or I'm just going to go to Zoom Standard because we already messed with it. So I'm going to go to Zoom, and number 6 is Standard, so it goes back to a normal screen. So then I'm going to see this graph. Notice that it hits it right there. I want the zeros, so I want the positive one. Again, time can't be negative. So I'm going to go ahead and hit second, and it's going to calculate again. So second and then calculate. We want to find the 0 this time. And it says left bound and right bound. It wants, because it hits it twice, you have to say, okay, either this one or that one. We want this one. So arrow to the right until you see the cursor show up. There it is. We want to be on the left side of that line. Notice this kind of gets wider this way. So hit enter when it's on the left side. Notice now it says on the right side. So I'm going to keep arrowing to the right until it goes across that middle, and hit enter again. And then the guess, hit enter, and now it says the 0, 1.5. Same thing. Okay? So either method still gets you the 1.5 seconds for the time. All right, and then part B asks you, what is the axis of symmetry? Well, if you look at this equation right here, we have x equals, in part B, axes of symmetry, x equals negative b over 2a. Well, looking at this original equation, which is right here, the b value is missing. There is no b. So that's just 0 divided by, and it doesn't matter if I say 2 times negative 16, because 0 divided by anything is 0. So the axis of symmetry is x equals 0. All right, let's take a look at this next graph. All right, based on the graph here shown, what are the solutions to this equation? So we're looking at solutions, and we're looking at this being already the graph of y squared plus 6x plus 11, because that's the graph that's shown right here. What are the solutions to the equation? Well, it has it, when does it actually equal 11? So if you take a look at this graph and draw a horizontal line at 11, so you're doing a y equals 11 graph, which is right here, we're looking at where do these two graphs intersect. And they intersect at basically 2 points, one right here and one right here. So if you follow those points down, you'll be able to find out what those values are. So if I follow this all the way down, that hits at -6 and this hits at 0. So we want to write down our solutions as, this is number 11. Oops, there's it. So x equals -6 and x equals 0. Those are the two x values where they intersect. Okay. All right, graph this equation and then answer the question. So let's go ahead and start by getting the vertex, because you'll need that first before you can figure out if it's a maximum or minimum, but I want us to know also what the value is. So let's start off with our vertex. So we have -x² plus 2x plus 3. So we're going to graph this. So in order to graph this, we first need to find out what is the vertex. So to find the vertex, I'm going to use x equals -b, so, or opposite of b, which will be -2, over 2 times a. A is -1. So -2 divided by -2 is +1. Now I'm going to plug that into this equation to solve for my y, so I get my vertex. All right, so we have -1² plus 2 times 1 plus 3. Keep in mind that this negative, pretend there's a -1 in front of there. So you're really doing the exponent first, 1², and then multiplying it by the -1. The negative will always stay when it's in front. So 1² is 1 times -1 is -1. Plus 2 times 1, which is 2, plus 3. So we basically have 5 minus 1, which gets us 4. So the vertex is 1, 4. So I usually like to make a little chart on the side here where I put my vertex in the middle. 1, 2, 3, 4, 5. So my vertex is 1, 4. And then I'm going to pick some x values that are more and less than that. So more is 2 and 3, less is 0 and -1. Notice it's in numerical order. So now I'm going to plug these numbers in to this equation to solve for my y values. Keeping in mind that these will be the same value and these will be the same y values. So between 0 and 2, I'd rather plug in 0 because that cancels all this out and leaves me with 3. All right, and then the same thing is plugging in either -1 or 3 into this equation. So I'm going to go ahead and plug in our, let's go ahead and plug in the -1. So -1², actually I'll write out the work here. So we have -1² plus 2 times -1 plus 3. So this is going to get us a -1², which is a +1. Keep in mind the negative stays. And this will be 2 times -1 is -2 plus 3. So we have -3 plus 3, which gets me 0. Now another way to fill this out is using the shortcut. If you remember that the a value is -1 and that the graph usually goes up 1 and then up 4. So if you go up 1, 1 times -1 is -1. So 4 plus -1 gets you the 3. And then 4 times -1 is the -4. -4 and +4 gets you 0. Either way, plugging in these numbers or not. All right, from there I'm going to go ahead and graph this. So I'm going to use a pre-made graph here and make it a little faster. So we have -1, 0. We have 0, 3. We have 1, 4, 2, 3, and then 3, 0. So this is what your parabola is going to look like. Keep in mind that these points are on this parabola. Okay, so let's go back and let's go ahead and start answering some of these questions about the graph. So part A asks us, what is the maximum or minimum of this? So maximum or minimum. All right, I always ask myself, is that the highest or lowest point? That is the highest point. So that highest point would be considered a maximum. Okay, and you can even say maximum at the 4. Okay, the maximum value is 4. It's always the y value for that. All right, and then part B asks you the axis of symmetry. Well, we already have the x value when we found the vertex. So x equals 1. Keep in mind the axis of symmetry always goes through the vertex. And then the last part of this was asking what the vertex is. So part C, we already found the vertex as 1, 4. Okay. All right, let's go ahead and look at number 13. It says, what is the axis of symmetry of the parabola that contains this coordinate? So notice that the y values are the same because, remember, it's symmetric. So we're really looking at the vertex being always in between the two other points. So it needs to be in between this -4 and 13. So to find what's right in the middle of that, some of you can count it inwards if you have a graph, but really it's the average of the two numbers. So -4 plus 13, and then split that in half so you know what the middle number is. -4 plus 13 is 9. So 9 divided by 2, you can leave it as 9 over 2, or you can write it as 4.5. Either way, if it's an axis of symmetry, it's not a number, it's an x equals. So you can write x equals 4.5, x equals 4.5, x equals 9 over 2. All of those are the same thing. All right. And then number 14, it asks you to find the axis of symmetry and the vertex. It's just a little more complicated because it has some fractions in there. You cannot fraction bust, otherwise you're changing this to not be y equals. So you need to keep the equation as it is and just use the formula. So for 14, part A, you have to use the formula x equals -b over 2a. All right, so opposite of 5 is -5 over 2 times a. A is 5 over 4. All right, so we have -5 over, and then when you're multiplying fractions, if you want to on the bottom, you can make this as a fraction as well. And I can cross cancel 2 and 4, right? 2 goes into 2 one time, 2 goes into 4 2 times. So it's really 1 times 5 on top, 1 times 2 on the bottom, so it's 5 halves on the bottom. You can't leave your answer like this. So there's two ways you can look at it. This is the same thing as saying -5 divided by 5 over 2. That's really the same thing. -5 divided by 5 over 2. And if you remember how to divide fractions, you basically keep the same number and you flip the second one and you multiply the reciprocal. Or you can say copy and then dot and then you flip it, 2 over 5. Either way. Then you keep in mind that if you want to, you can do that again, put this over 1. The 5's cancel, and then it's -2. So you have all this equals -2. All right, so you have your axis of symmetry for part A as x equals -2. And then part B is finding the vertex. Well, you already have the vertex, or the x value of the vertex. You just need to go back and find the y value. So I'm plugging -2 back into that original equation. I have y equals 5 over 4 times -2 squared plus 5 times -2 and then minus 1/3. All right, exponents first. Leave the 5/4. -2 times -2 is 4. And then I'll go ahead and leave this and multiply it out in a minute. So we have 5 over 4 times 4. Keep in mind this is over 1, so really these cancel, and you're just left with 5. 5 times -2 is -10 minus 1/3. All right, let's simplify this part right here. So we have y equals 5 minus 10. Well, that's just -5 minus 1/3. You need a common denominator to subtract. So I'm going to go ahead and get that into a common denominator of 3. Keep in mind this has a denominator of 1 right now. So I'll have to multiply the bottom and top by 3. So I have -15 over 3 minus 1/3. So that's going to give me -16 over 3. And I cannot reduce 16 over 3. So I have my y value. So my vertex is -2, which is my x value, comma, my y value, -16 over 3. All right, And then number 15 asks you to, there we go, they tell you that the vertex is 0, 7, and a point on the parabola is 3, 6. And write an equation for the parabola in standard form. Okay, so on number 15, the first step is to use this vertex. I'm going to go ahead and write it in vertex form first, and then multiply it out to be standard form. So first step is to get it into our vertex form. So y equals a x minus h squared plus k. All right, I know my vertex is 0, 7. Notice I can't just use x squared because my vertex is not at 0, 0. So 0 goes inside the parentheses. So I'll write it out, minus 0 squared. And then the 7 goes outside. Opposite same. And so x minus 0, that's just going to be x squared. The reason why I don't have parentheses anymore is because the only thing that's squared is x, and that's automatically known here. So the only thing I really need is this a value right here. Well, to find that, I have a coordinate, 3, 6. So I'm going to go ahead and plug in 3 in for my x and 6 in for my y. So here we go. Plugging in, my y is 6. A is going to stay, that's what I'm solving for. X is 3 squared plus 7. All right, so 3 squared is 9, and usually write your number or your coefficient before your variable. All right, I'm going to go ahead and subtract the 7 to the other side. And then last step, I'm going to divide by 9. So negative 1/9 is my a value. All right, now I'm ready to plug that a value into this equation to complete it. So I have y equals a, which is negative 1/9, x squared, and then plus the 7. Number 16, what's the vertex of that graph? Again, we're using a lot of negative b over 2a's here, but that's what we need to do here. So number 16, we have x equals negative b, or opposite of negative 16, positive 16, over 2 times a, which is negative 2. All right, 16 divided by negative 4 is negative 4, so that's the x value of the vertex. Now we have to plug that back in here to solve for y. Negative 2 times negative 4 squared minus 16 times negative 4 plus 10. All right, do exponents first. Negative 4 squared is 16. Oops, plus 10. That's a plus. All right, y equals negative 2 times 16 is negative 32. And then negative times the negative is positive, and multiplying that, let's see, 6 times 4 is 24, 2, 4, 64. And then negative 32 plus 64 is 32, plus another 10 is 42. All right, so our coordinate for our vertex is negative 4, 42. And then the last problem, we have a dolphin that jumps out of water, and the quadratic function, again, that's modeled right here for us, models the dolphin's height above the water in feet after t seconds. How long is the dolphin out of the water? So we want to find out how long is this out of the water. So for number 17, I'm going to use my graphing calculator again. You will learn how to solve for this algebraically next unit. Okay, so I'm going to go ahead and go into y equals. I'm going to change this to be 16x squared plus 20t, or 20x. All right, and now what I'm going to do is I'm going to go ahead and graph this in the standard form. So I'm going to go zoom and then standard number 6 just so we can see it again in normal form. So this is what the graph is. So the dolphin basically jumps out of water right here and then goes back in. Remember when it says how long? That's your t, and t is your x value. Okay, so this one is time at 0, so that's when it jumps out. And how long is it out of the water? We want to know what number that is. Now I know it's a little bit more than 1, but how much more than 1? Well, let's find out. That's called a 0. Zeros are where it crosses the x-axis. So I'm going to go ahead and hit the second button and then calculate again. I want to know the 0, which is number 2. Okay, so I'll do that again. Second, calculate. You want the 0, which is number 2. And then I want to know what that is over here. So on the left side and the right side of that. So I'm going to go ahead and arrow over. So I'm over that, so I'm kind of closer in. This is the left side of the parabola. Hit enter. Keep arrowing to the right, so now I'm on the right side of the parabola. Notice that line is dashed on the left side. Now we're on the right side, and now it's dashed on the right side. See how there's a little space in between? That's where my answer is going to be. So I'm going to go ahead and hit enter one more time for it to guess. And then there it is, 1.25. So it was out of the water for 1.25 seconds. Right, and part B says, what is the maximum height above the water? So maximum height is the very, very top. So again, I'm using my graphing calculator to figure it out. And I'm going to go ahead and hit second again. And then I want to calculate. So calculate's right here. This time I want to know what my maximum is. How high was this? So you can press down until you hit number 4 or just hit the number 4. Notice it says left bound. I'm not on the left side of that very top. You have to be on the left side of the top, and then we're going to go to the right side of the top. So I'm going to arrow to the left until I'm on the left side of this graph. Now I'm on the left side of that very top. Hit enter. Arrow to the right, so you're on the other side of that. Hit enter again. And then go ahead and hit enter one more time, and that'll get you the top. The maximum is not an x value. Remember, maximum and minimums are the y value. So the height is 6.25 feet. All right.